Hey guys, so today we're going to be doing a little bit of trig, a little bit of solving some right triangles here in a little bit of an application form. So we're going to be given a situation dealing with triangles where we're then going to have to figure out the missing information. So let's jump right into this problem here. This one says that a string running from the ground to the top of a fence has an angle of elevation of 45 degrees. The string is 10 feet long. What is the distance between the fence and where the string is pegged to the ground? So I'm going to draw this situation out first. If you're not given a drawing for your particular problem, I really feel like it really helps if you do draw it out, just a little bit more visual so we can exactly see what's going on. So if I have a string running from the ground to the top of a fence, so here I'm just going to pick that point, that's where I am on the ground. So here's our ground, okay? So we have some fence over here, and we're going to take a string and we're going to run it from the ground to the top of this fence. And it says that the angle of elevation, so this angle over here that is then formed between the ground and where the string is run, it says that that angle is 45 degrees. So we do know that. We also know over here the fence and the ground form a perpendicular angle, and that is our right angle for our triangle. So we should know then that this is also a 90 degrees. If we wanted to find the angle of this one up here, we should be able to do that because we know that a triangle equals 180. So we can take 180 minus 90 minus this 45, and we also know that this angle up here is going to be a 45 degree angle then. That's not what this question is asking us though. This question says that the string is 10 feet long. So remember, the string is this line right here from the ground to the top of the fence. It said that this was 10 feet long. It wants to know what is the distance between the fence and where the string is pegged to the ground. So it wants to know this distance here, right, where the string started along to where this fence is. So that's going to be our x. That's what we need to figure out. So we're going to use just definition of a sine, cosine, tangent in order to solve this triangle here. So remember, sine, cosine, tangent, the best way that I get that memorized and stuck in my head, hopefully you have heard of SOHCAHTOA. Right? If you have not heard of SOHCAHTOA or you're not familiar with sine, cosine, tangent, I highly recommend going back and doing a little bit of a review video before jumping into this. But what we should know is that sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, right? The A, so A adjacent, H hypotenuse. Whereas tangent is equal to O is opposite, A is adjacent. If any of this did not make sense, you definitely need to go back and do a refresher before this problem. So what we need to figure out, so here we have this angle we're given. We're given that this is 10 feet long, and we're solving for this line right here. So we want to try and figure out, are we using sine, cosine, or tangent based off of our angle? So our angle is this one right here, 45, we know that. The other two pieces of information, one that we know is the 10, one we need to find out is this x. And in reference to this angle, the 10 is the hypotenuse, right? It is our diagonal of our right triangle. The diagonal of the right triangle will always be a hypotenuse. So our other options are these two over here. So in reference to the 45, this side over here is opposite the 45. All right, so this is our opposite, but we don't know anything about it. So that means this line right here that we need to solve, this is our adjacent. Remember, adjacent, it's right next to our angle. It's not the hypotenuse. Again, the diagonal is always the hypotenuse. So that means this line right here has to be adjacent. So we're solving for adjacent, and we know the hypotenuse. So adjacent, hypotenuse. So out of sine, cosine, and tangent, which one has adjacent and hypotenuse? So, right, so that means it's going to be our cosine right over here. Cosine is equal to adjacent over hypotenuse. So that means we're going to be using cosine for this particular problem. So the way that that looks is we're using cosine because it has adjacent hypotenuse, and we know that we're taking cosine of 45 since that's our given angle here. And cosine is equal to adjacent divided by hypotenuse. So our adjacent is our x, that is what we're solving for, over our hypotenuse, which was given to us, is 10. So we are solving this problem for x, and then we'll know the distance between where our string was set up and the fence. In order to solve this problem here for x, so we're going back to solving equation skills. In order to get rid of x, we need to get rid of the 10 first. This is a division, so remember when it comes to solving equations, you do the opposite of what you have. To get rid of the division by 10, we multiply by 10, making sure that we multiply both sides by 10. On the right-hand side, the 10 and the 10 cancels, leaving us with x. On the left-hand side, we now have 10 times cosine 45. If you have a scientific calculator, you can type that right into a scientific calculator. You can also do this by hand, knowing that cosine of 45, I believe, is 1 over the square root of 2, or simplified square root of 2 over 2. So you can either type this into your scientific calculator, get an answer, or I know that cosine of 45 is square root of 2 over 2. And if we simplify this, putting that 10 over 1, 10 times the square root of 2 is 10 square roots of 2, over 1 times 2 is 2. All we have to do is simplify this fraction. We know that 10 divided by 2 is 5, and drop down the square root of 2 with that. So that gives us our answer here for what x is. That means x is equal to 5 square roots of 2. That is the distance between the fence and where the string is pegged to the ground. Otherwise, that's it for this problem.